Hello everyone. In this video, we'll be going to discuss a complex number problem which came in B.Math B.Stat 2019. And it's a third problem here. As you can see that you have been given a domain omega which is nothing but set of all complex numbers whose modulus of the imaginary part is lesser than equals to 1. And you have been given a function that is z square plus 2. So you need to apply this function on this domain, and you have to find out where this domain will go under the mapping z square plus 2, and you have to draw the region as well as justify your answer. So let's do it. Okay, so here is our domain omega, and if you visualize it graphically, so it is basically this region which is between the lines y equals to 1 and y is equals to -1. So we have to find out that under this map, that is z square plus 2, where will this domain get mapped and how will it look like. So if z is equals to x plus iy, then f of z is equals to z square plus 2, which is nothing but x plus iy whole square plus 2 is equals to x square minus y square plus 2 plus 2ixy. So this is the real part and that's the imaginary part of the function f of z. So now the main thing is that how do we attack this problem? So for that, what we do is we check where the boundary gets mapped first. Okay, so we check that where the line y equals to 1 and y equals to -1 gets mapped, so that we might get a boundary for our image. So let's see, if we take, if y is equals to 1, then f of x plus I1 is equals to x square plus 1 plus 2ix. Now I can write this as 2x by 4. Okay, 2x whole square by 4 plus 1 plus I 2x. Why did I write it in that way? Because I have 2x here in the imaginary portion. So I somehow tried to relate the real portion and the imaginary portion. So now I can see that if I take y is equals to 2x, then my x, that is the real part, is nothing but y square by 4 plus 1. Okay, which is a parabola, right? If y is equals to -1, then f of x minus I is equals to x square plus 1 minus 2ix is equals to, now again I will be relating the imaginary part and the real part, so I can write them as minus 2x whole square by 4 plus 1 plus I times minus 2x. So again here, if my y is minus 2x, then x, the real part, I can write it as again minus 2x whole square by 4 plus 1, which is again nothing but y square by 4 plus 1. So you see that both this both the boundaries get mapped to the same parabola. So, and how will this parabola look like? So that will be nothing but, it will look something like this parabola, and which will cut here at 1, as you can just see the values. So now how do we determine the image? Just plug in any other point which is in the domain. So any other point which is inside the boundary. And you see, if you take the point 0, 0, then where does it get mapped to? So under the map F, it gets mapped to 2, which is here. So now I claim that the image of the domain under the map F is equals to all those complex numbers W, which can be written as U plus IV, and those are in complex plane where we have U is greater than equals to V square by 4 plus 1. Okay, so that's the parabola that we had. If W is equals to U plus IV, and that is equals to f of z for some z equals to x plus iy in the domain omega, then W is equals to x square minus y square plus 2 plus 2ixy. And so we have that u is equals to x square minus y square plus 2, that is the real part, and the imaginary part v is equals to 2xy. And so v square by 4 plus 1 is equals to x square times y square plus 1, which is lesser than equals to x square plus 1. So I'm just removing y square, and this is lesser than equals to x square minus y square plus 2, since mod of y is given to be lesser than equals to 1, and this is nothing but is equals to u. So what we have proved here is that given any point in the domain omega, f of omega is a subset of u plus iv, all those complex numbers, such that u is greater than equals to v square by 4 plus 1. So we have proved one side, so remaining other side we have to prove. So conversely, let u be greater than equals to v square by 4 plus 1. Then we have to show that w, which is equals to u plus iv, is in f of omega. So now here I divide this thing into some cases, into 3 cases basically. So this is case 1, where I choose my u to be greater than equals to 2 and v to be equals to 0, and then we take x to be equals to root over of u minus 2 and y to be equals to 0. And so you see that f of z is equals to nothing but u, which is equals to u plus iv, as v is 0, and that is equals to w. Okay, coming to case 2, now we choose our u to be greater than equals to 1 and lesser than 2, and again v is equals to 0. And now we take here x to be equals to 0 and y to be equals to root over of 2 minus u. So now if you notice that this 2 minus u is strictly greater than 0 and lesser than equals to 1, because of the condition that we have taken in this case 2. Okay, and this implies that z, which is equals to x plus iy, which is in the domain omega, and f of z, again by the definition of f, if you see, then this is coming out to be u, which is u plus iv, and which is equals to w. Okay, now my last case, that is the third case, I'll be taking u to be greater than equals to v square by 4 plus 1, and v is not equals to 0, and I'll let my y to be equals to u minus 2 whole square plus v square minus u minus 2 by 2, again whole root over. Okay, and my x to be v by 2y. So all these values of x, y that I am taking, so these are all back calculations. So if you just calculate it and see, you can easily get what x and y you need. So now I have to show that my y that I've chosen, its modulus is lesser than equals to 1. So I can write u minus 2 whole square plus v square is strictly greater than u minus 2 whole square. Now here our v is not 0, and this is equals to u square minus 4u plus 4 plus v square, which we can write as u square plus 4 times v square by 4 plus 1 minus u, and which is strictly lesser than u square because of the condition that we have chosen in our case 3. So this applies here. Okay, so now what we can say is that root over of u minus 2 whole square plus v square is lesser than equals to u, and is strictly greater than u minus 2. And now if you just take negative u everywhere, so this is coming out to be u, and add 2 everywhere, so this is coming out to be negative u minus 2 is lesser than equals to 2, and I must divide it with 2. So this is the right hand side coming out to be 1, and the left hand side is 0. And now if I again take the root over, and still it will be lesser than equals to 1 and greater than 0. So I have here y is lesser than equals to 1 and strictly greater than 0. So my y satisfies the criteria of the domain. Okay, so now again I take z, so x plus iy, which is in my domain omega, and then f of z will be equals to x square minus y square plus 2 plus 2ixy, as we have seen earlier, and this will be equals to, now remember I took my x to be v by 2y, so this is coming out to be v square by 4y square minus y square plus 2 plus iv, and this is equals to v square by 2 root over of u minus 2 whole square plus v square minus u minus 2. So I'm just putting the value of y now, and this is negative of root over of u minus 2 whole square plus v square minus u minus 2 by 2 and plus 2 plus iv as they are, and this is equal to, so if you rationalize this thing, then this will become, so I'll be multiplying with root over of u minus 2 whole square plus v square plus u minus 2 to rationalize it, and so you'll see that v square and v square will get cancelled out, and so I'll be left with u minus 2 whole square plus v square plus u minus 2 by 2. And this one, let it be as it is. So this is u minus 2 whole square plus v square minus u minus 2 by 2 plus 2 plus iv. And now if you just simply add the first two, so you see that you will be getting that 2 which will get cancelled out, the 2 there, and a u will also come, so u plus iv. So here we have proved that the set w is equals to u plus iv, where u is greater than equals to v square by 4 plus 1 is a subset of f omega. And so we have proved that f of omega, so if this is our equation 2, then you will see that from our equation 1 here and equation 2, we can say that they are equal. And what will be the sketch of the domain? As I have shown you earlier also in this video, so it will be that parabola cutting the x-axis at 1 and every complex number here. So this parabola is going and every complex number that you can have here, so this whole region.